agenda, and we're going to go through some basic key building blocks and then focus on the mixer, because the new mixer is the most complicated piece of machine on this overall system. And this is the new system, Midas M32. It's very fancy. It's very capable. And then these terms, routing, EQ, gating, compression, you will encounter several times, or at least quite a few times, once you get into using the new system. Part 2 of the presentation will be on the operation. That's to show you how actually to work the hardware. And we'll start from powering up the whole thing, get into different modes. These are pre-stored configurations of the settings of this mixer. And then we have other whiz bangs and other maybe new terms that we will encounter. DCAs I will cover later. And then we will have support for people who would like to use in-ear monitors, mostly for the vocalists. And then we have these delayed speakers are just, what should I say, fill speakers for the rear, the rear end of this big hall. It's no big, nothing really special. Reverb and delay is fancy in terms of it adds effects to an audio mix. Normally in a sermon, we don't use it that much. When you do a recording, it may come in handy. So I just mentioned it during the talk. And then I'll show you how the audio paths, meaning where the wires go, or logically where the flow of our audio is. And then last but not least, how to properly power down the system. Okay, so there's a part 3. And if you are still awake by then, our illustrious leader, Mr. Ken Tang, will be telling us how to properly maintain, upkeep, and store things and set things up. So these are for mostly existing coworkers. Okay, so here's the kind of a main course. This is an old diagram. Oh, I gotta shrink this a little bit. That I presented last year, maybe 2 years ago. And basically on a typical sound system, you'll have some floor mics, people holding microphones, singing into it, whatever. We'll have wireless mics like the one that I'm wearing now. And then we'll have a computer, which, we broadcast our Jiaxin and kind of feed it all into this big box, which is actually a mixer plus some, the power amp is separate. So yeah, so this is the mixer, and then we get 2 main channels out, and that would be kind of very much like the system in our old sanctuary. And I drew this last time, and this is actually a pretty detailed depiction of how things are wired up in the old sanctuary. Some microphone lines through some copper cable up the ceiling and feeding into our mixer. Some wireless microphones, we put receivers anywhere we can and then feed it into the mixer. And then a little bit whiz bang, but basically we got 2 main outs, L and R, and that feeds into a thing that kind of bumps the 2 lines into 6 lines, and then we get 6 outputs to drive different speakers placed at various points in the sanctuary. So that's the old system. Now we go on to new system. Let me shrink a little bit. Okay. Here, it's actually very similar. We got a little bit fancy. We have floor pockets, and the L, C, and R is per trade kind of convention, meaning the way they do it is you stand on the stage and facing the audience, and that is left. This is right. This is new. So what is new is the pockets actually feeds individual cables, and individual cables got brought into a big panel down. If you can see it, is right down there. There's a big, not big, but many connectors. So it's actually just an interconnect between that panel and the connectors in the box. Now, so how does it get into our mixer? It gets fed into, well, it's through a bunch of patch cables. So you can wire them whichever way you would prefer and map it into this, what we call the stage box, which is a little bit of, which is a small rack containing what is called a digital snake, which takes probably about 15, 16, well, 16 maximum, but we're doing about 14 wires, and convert it into one wire, a Cat5 cable, and that particular interface is called the AES50. And that single wire goes up the ceiling, and I mean cable, not wire, sorry, and it gets plugged into the Midas mixer. And the Midas mixer then can demultiplex all those lines and brings out your 14 individual channels. And from the mixer, outputs goes into what is called Bose DSP, and basically they can do fancy things. They can map whichever input to whatever outputs and then drive different types of speakers. The hall speakers are these rectangular things you see kind of hanging down the ceiling. The subwoofer, mainly for the very low frequencies, are, where are they? Here, up where my finger's pointing. Two of them are here, and then two of them on the other side. And those are mainly for real deep, low-frequency outputs, such as drums and bass guitars. This is a block diagram of our current wiring. And I don't expect to be spending too much time on it, but basically, as you can see, all these complications, this digital snake go through just one wire called the AES50, I think it's this wire, and then it becomes, it goes to this big thing called Midas M32. And then it goes into the power amps. This is the Bose DSP, and then the power amps are here. So you don't have to study it a lot, but if you're really if you are really into supporting this whole setup in the future and maintaining, meaning addition of new wiring, new microphones, changing the current setting, then it helps to understand at least the major pieces of this thing. Okay, so why I say anatomy of mixer is to help prepare you for what's coming on the new mixer. So let's look at what we used to have. It looks very simple. You have, in our old mixer, and a lot of you have played with it, you have a bunch of inputs, microphone lines or cables directly plugged onto the mixer. So you actually plug a wire into an input, and it actually gets directly into what is called a channel, and there are 24 of those. And then remember there's a little knob that's called the trim, and if you wonder what it is, I'll show you in this next picture. So that little triangle I dropped is this little knob called the trim or the gain. Now this, usually people don't pay too much attention because we all think that, we control the fader. That's how we control whether I want loud and the soft output. But this thing is important because you want to tune it so that depending on how strongly the person speaks into your mic, you may overload the channel. And once you get red light in here, no matter how far down you turn it, you can still get the red light, meaning it still overloads your preamp. So that's why you adjust the trim so that on this full range movement of your fader, you don't overload the front end meaning the preamplifier, and which means then you try not to get too many, I think it's amber lights or whatever, maybe red lights, depends. And so that's why that is called the trim. That's kind of industry speak. And then the signal goes into a simple, I think a 4-band parametric equalizer. I did something wrong. You don't have the dynamics, and you don't have the gating on this mixer, just the EQ. So I think your slide is right, except that your slide is kind of offset. So it goes into another fader, not another, but this fader is the one you just saw, and that's the one you normally play with. So then it goes into this fader, the signal. So you're looking at it vertical now, if you follow the diagram I just showed you. So this is the 4-band equalizer, and then the signal goes into here, and then you control the loudness. Okay, then your signal goes into what is called the main bus. Follow this main line. And there's only 2, meaning it's left and right output, that's all. Now you have a choice then to add your signal to any or all of 6 auxiliary buses. And they're actually called auxiliary sends in the old terminology. Aux send for short. And so if you run out of outputs because you only have 2 here, we can treat these as also an output and use it for different things. And in the old sanctuary, one of these is used to feed the social hall and the lobby, and then one of these is used to feed the social hall. There's a mixer in the social hall, and you can pipe all the audio of the main sanctuary to the social hall. And then another one goes to the front lobby, and then I think the other ones are spares. Okay, so that's the limit. You get 6 aux send buses, and then you get 2 main outs, and that's all from the old Behringer. So any questions so far? Okay, so just put in here to kind of impress you. This is a block diagram of the new mixer. So if you see these, you can see a lot of buses here, much more than the 3 I just drew in the last diagram. So let's move on to my simplified slide. Okay, so this is the interesting part. So the new Midas mixer actually has the input. You don't just plug it into a connector that says bus number 1, or no, I mean channel 1. It's no such thing. It's just called connector 1. And then inside, actually, you got to do routing to route it into the channel of your choice. And so that's the main difference between this digital thing and the previous analog design. Okay, so here you have a little bit more fancy things. You have dynamics, which is effectively a compressor, and that what the compressor is if you talk really loud into a mic, if I engage it, the circuit will sense that it's too loud per your setting, and then lower the gain of the channel, and so that you don't get into the red zone. And the gating is kind of the opposite, is for you to eliminate stray noise as you speak in microphone, and if I'm standing next to, let's say, somebody operating a electric grill, that's a bad example, but some people talking in the background and talking into it. And then the gating says, it depends on the threshold that you set. I don't let any signal through until the input goes above a certain level. So the experienced DJs use gating to add quote unquote more punch to their audio. And one practical use is when you have a drum set with a kick drum, snare drums, toms, and then the cymbals, they use it to gate the snare, because those mics can pick up other sounds from the stage. Okay, anyway, this is a dangerous part. So the thing goes through the fader, and it can go into the main bus, and instead of 2, we get 3. There's the left and right and the central, although we don't currently use the central, so we only use the L and the R. Okay, so where's it? LRC? I just use the L and R. And then notice there's 16 mix buses, and actually there's no aux bus. You don't see an aux bus. And I think this 16 buses replaced the old aux sends, because effectively they do the same thing. In the old design, they do aux sends, and the purpose is to allow you to feed it into some fancy processors, reverb machines or some sound conditioning machines, and then you feed it back, and you get an input called aux return in the old design. Now this guy actually has aux returns, so you can pick out any signal from the mix bus, do your own processing, and feed it back into the aux return. So now, interesting is, and I just picked it up from the block diagram from Midas. When you do aux return, you can only go back to the main bus. And there's a reason for that, right? Because if you take a signal from here, feed it into some other things, and then loop it back into the same thing, you get an endless loop. So they don't want you to do that. Okay, but what is this sent on fader? That's actually, and I want to go back to the previous photo. In this photo, if you want to send a signal to a particular aux send output, see, we already put tapes on 4 of these. This knob here is how you add your signal into that aux send. So each channel, you can twist this knob and you can send it to an aux send. And then at the end, you have another gain pot here, and this corresponds to the first aux send, and you see there are 6 of them, because I have 6 aux send buses. Okay. So remember now, you have a knob that adds your channel to an aux bus. So now go back to my diagram on the M32. Okay, so you expect to see the same knob here, except it's not a knob, and there's no separate thing. So remember there's such a thing. I'll show you where it is. Okay. And then the rest is pretty straightforward. There's a new design. It's called a matrix bus. And why is it called a matrix and not just any bus? Is matrix bus allows you to add a bus and combined with other things of your choice, and it becomes they call it a matrix. So you don't feed directly a channel into a matrix. You can only feed a bus into a matrix. That's how I kind of viewed it. So a matrix bus is you take these things a little bit back, and it becomes your matrix bus, and you can take an output of it. And we currently use it to kind of power the subwoofers.
I want to ask you, under what condition, as applications, do you use the main mixer or?
It's on.
Huh?
It's already on, Ken.
No, I just want to know the applications.
Mm-hmm.
Under what situation we need to use the main, what situation we need to mix, what situation we need to use matrix.
Okay. You'll see later. Because all you're interested in is the main. Everything got mixed into it if you want. Of course, you can choose not to. You can just turn your fader all the way down and you don't get mixed into the main. But otherwise, that's how we used our old machine is we put everything into the main mix. Okay, these buses are fancy. You can use it to do other things. And today, if you ask me, there are two buses that goes to the outside. You know, where your restroom, you hear music in the boys' room. So that came from actually two of these, L and R. You know, each is stereo. It takes a pair. And then we used two for feeding signals to these two stage monitors. Okay, so actually they're very useful. That's why they do 16. In fact, we ran out of them. We are running out of them if we're not careful. The matrix is actually more complicated. You don't have to use them. It's a good question. Any more questions? Raymond, did you get a handout, Raymond? Yeah. I wonder where Jennifer Shao. Oh, you have. Oh, yeah. Okay. Thank you. Okay. The reason I put colors on these is, remember I say in the old design, you turn that knob and you add your signal into the aux bus. In the new design, you got to use what is called a send-on fader switch and then do something to add your channel to the mix bus. So remember that part, because we always get caught off guard with this thing. Either you engaged it without knowing it, or you forgot to engage it and then search for why my signal doesn't appear. Okay, and then this, I shaded it in color, is you can only use bus sends, and that's actually a separate set of control, to add any of your buses onto the matrix. So you cannot use fader, send-on fader to add your buses onto the matrix bus. Okay, so I'll show you when we get into the picture. Okay, any more questions? I think that's pretty much all we need to know. This is here just to let you know that, yeah, there is something called an aux return, and then, you know, you can play with it a little bit, and then it goes to your main bus, and that's about it. And actually, today, we're not actually using it as an aux return, we're using it as an input. And Albert likes to put his cell phone and play music and play it for the sanctuary. So I summarized these just to help you kind of not trying to be too confused. And I say all channels can be mixed onto the main LR bus. And remember, oh, the fader flip is the same as the send on fader thing I showed you earlier. So to add to any of the mixed buses, you use the fader flip, but to add on the main LR, you don't. It's kind of there by default, unless you explicitly cut it off, and I'll show you how. Channels can be added to any of the buses and using fader flip, and that's what I just said. Main LR bus plus any of the 6 buses can be added to one of the 6 matrix, and that's how I just mentioned using that thing called a bus send. And then this is kind of the most kind of like confusing part, or one of the most confusing part of this design is input connectors are not connected to any of these channels, meaning the one with the faders, unless you route them. You specifically tell the machine that I want this input connector to be connected to a channel. And this is kind of like a software thing. I mean, there's a screen for you to push and a whole bunch of settings in order to do the right thing. And it's pretty hard. If you don't understand it, it's totally confusing. Ken and I, when we first got the machine, plugged things in, we got certain audio output, we were happy, and we have no way of shutting it off, we don't know how. So those...
Frank, the number one there, all channels will be mixed, right?
No, it can be mixed. There's a way to cut it out. I can show you.
Automatically it's mixed.
It depends on how you set it, right? If I cut it off, store it, and then you recall the scene, you won't get it.
Unless you explicitly exclude it, right?
So I have not seen the defaults on this mixer, right? So I won't say that by default they're there, but you can assume that by default they're there, but just don't count on it, because I have touched it. Okay, but that's a good point. No, Ken, let me show you this.
Frank, one more question. For this, for those mixed buses and the matrix box are predefined the usage, so that means everything has been pre-configured?
Yes and no. For matrix buses, I think there's still 2 left. You'll see it. Yeah. There's only 6 available. I think we used up 4 of them.
So do we see, okay, mixed buses 1 doing certain thing, mixed buses, we have predefined?
Yeah, you can do whatever you want, and then you better remember how you did it and where you put it.
So right now we're having predefined already?
Yeah.
Say for mixed buses ones for maybe for instrument. Yeah. Oh, that is the way we do it. Okay.
Yeah, we took 4, and each of those 4 will feed the in-ear monitors. So that went, that already accounted for 4. And then we used 2 to mix into the USB recorder for me to record things on a USB drive. What else? And then 2 for the stage monitors, and 2 for the outside, the men's room and whoever. There's a chart I did. I can show you. Anyway, okay, so back to Ken's comment of everything should be on the main bus. Here. This is the old machine. Okay, on the old machine, see this line of push-button things? That's how you add your channel into the main bus. If you're not careful and release that, your signal will go nowhere, or at least will not go to the main bus. And it happened. It happened one time. I don't know who released this button. It came out. Nobody realized it, and then one day, I think it was during a memorial service or something, and they say, it doesn't sound right. We only hear one side, can only hear something. So it turned out somebody released this button, and this is the podium mic, okay, if you recall, channel 1, okay. And the noise, the sound they hear is actually from aux 1, which is sent to the floor monitor sitting right by the organist. So they say, it doesn't sound right, it sounds far away. So be careful. You have to explicitly add your thing. But you can assume it's added, but don't be, don't be too confident. So same goes for the new mixer M32. I mean, it should be there, but if it's not there, then maybe you know where to look, or hopefully you know where to look, okay? Now I got to move on. So no more questions on, any more questions on this thing is kind of my summary, and as you play more with the system, you will kind of understand and appreciate those little things. Okay, so this is to show you kind of what you can touch and also what you can do. Now, 32 channels. These are the input channels, but there's only 16 faders. Okay? So, where are the other 16? You press a switch and you go to the other 16, and this is the switch. Okay, there's a push button here. So right now, this push button is pressed, and so you're getting the first 16 channels on these faders. If you push this button, then you get 17 through 32 here. And if you push this button, you get the aux return in here and then some other things in here. And then if you push this, you get, at a glance, all 16 of the mix buses here. Okay? And you don't see it very clearly, but there's a push button here. This is the send on fader, which is also called a fader flip. This is the one that will come back and bite you if you're not careful. You have a mix bus, and the mix bus is accessed on this side of the machine. There are 8 of them. And I just mentioned this thing has 16 mix buses. So how do I know who I'm getting? This button is the first 8. This button is the second of the 8. So buses 9 through 16. Buses 1 through 8 is this button, okay? This button I'll ignore for the moment, but it's important. It'll burn you if you let it go uncontrolled. This lets you look at the 6 matrix buses. Okay, so I mentioned there were 16 mix buses. You access them by these 2 push buttons. There are 6 matrix buses. You access them by this button. Then, fader flip allows you to engage any of these 32 channels onto a particular mix bus. Not matrix, mix bus. Okay, any of the 16. And you push this switch, then it effectively brings these faders to what I just drew as that other fader. I don't know how to describe it, but it actually then brings you to this fader. If you don't press that switch, your faders are actually this fader. So that's the most tricky part on this machine. But if you don't care about adding signals to a particular mix bus, then you don't worry about it, except that if some guy before pushed this and then you keep pushing your faders and nothing happens, then you'll know why. You'll get to appreciate it once you play with it more. Okay, so I'm now into the key controls. Maybe I jumped a little bit ahead of myself on the last picture, but Here's the gain trim, and where's the gain, meaning the trim? It's actually this guy. Okay, so this is the little pot. A pot is that little knob that it's a short for potentiometer, but we just call them pots. Okay, what are these two push buttons? One is called the plus 48 volt, and it is required by the condenser microphones to have plus 48 volts. So in my previous training, I showed kind of what is a condenser mic and what is a dynamic mic. Condenser mics don't have a coil, don't have a magnet, and somehow it relies on capacitance to kind of convert your vibration into audio signal. And how do I pick up the vibration? You charge up a capacitor. How do you charge up a capacitor? You need power, so that's why you need the plus 48 volt. Okay. The other thing is called a phase flip. And in the old days, when you hold on a microphone, the outputs are not properly polarized. So you can plug it in, plus side on the top, minus side on the bottom, and everything works fine. Someday you maybe buy a cable or another mic that has the polarity reversed. You hold a microphone, you walk up to the stage, woo, and then lots of feedback. So in those days, when that happens, of course, you cover your mic and try to reduce the feedback if you're lucky. But chances are you can get rid of that feedback by flipping the phase. So that switches the output, plus to minus. These days, almost all the microphones and all the equipment are designed so that they are already the proper phase, meaning you don't very seldom have to touch this button. Now, there's still feedback, if you're not careful. Like, if I turn up my gain here and then talk under a speaker, then you get what is positive feedback, and it becomes a big squeaking sound. Then there's a preamp config section, and then there's a EQ and dynamic section, and I'll show you where they are. This is the preamp config section. At this time, the key use is to engage what is called a low-cut filter, but if you don't need it, then don't use this section. Okay. Now this is, you don't see it clearly, but you'll get to when we go, on part 2, I'll show you what to do. This is the gating section. I don't normally have to use it because typically on a sermon, you just don't need it. Everything else is quiet. This is the compressor. I use it quite a bit, especially when worship team is on. So each vocalist, they can have a wide range of output, from the lungs or whatever. And on the loudest part, you may overload the channel because on the lowest part, if you don't give them enough gain, you don't hear anything. So here where the compressor come in, and then you say, oh, if it's too loud, above a certain preset threshold, I will lower the gain of my channel automatically so that I do not saturate the channel. So I'll show you how to do it and what it actually looks like in the part 2. This part is what we use the most. This is the equalizer. Equalizer is, I think did I do a definition of what is equalizer? There's an equalizer. Where's the equalizer? Okay. Several pages down, I'm now on page 20 of 32. Equalization is a process of adjusting the balance between frequency components in an electronic signal. Kind of all-inclusive, okay? Basically, it just allows you to boost the strength of certain frequencies and lower the signal on other frequencies, depends on how you choose them. In this mixer, on this equalizer, you have four bands. And these bands has, of course, a center frequency which you want to work at, and then you can either boost that frequency or weaken, attenuate that frequency. How does it affect, how narrow is your band, right? You adjust it with another knob called the width. I'll show you later, but I'll stay on this chart. I'll stay on this slide for the moment. And you practically change the width of your bell curve. And so as you widen the width, that means you are affecting more nearby frequencies. So this type of equalizer is called parametric equalizer. So you set a parameter, and if you are the engineering type, you narrow the bell curve and you have what is called a high Q. And basically the width changes your Q. So what is this used for? Mitigate unwanted frequencies, echoes, hums, sibilance. We're getting fancy equipment, and at times we get certain frequencies which we don't like, or certain manifestation of certain frequencies. So sibilance is actually a manifestation of certain high frequencies when people say the word S beginning with S and Z and those things. And this mic is pretty tolerant, and it doesn't accentuate those. But even at certain CDs, when vocalists are singing, the S would come out as pretty sharp and kind of whistling. That's the sibilance. And you can reduce the sibilance by doing EQ. The other effects, let's see, this I forgot to mention. This mixer has 8 effects machines at the tail end. You can attach them to any of your mix buses, but there's only 8. And one of the 8 has what is called a de-esser, D-E and then E-S-S. And DS is the process of reducing the S. So it's like decompose, or, it's called a de-esser. That's kind of like audio engineering talk. Okay, so effectively you make the audio sound good. And there's a price to pay, and of course you boost it or attenuated frequencies, you just don't hear them, and the thing may sound a little bit different. Case in point is Pastor Cho this morning. So he was using a lavalier mic, and that mic picks up audio from every which direction. It's called an omnidirectional mic because he wears it here. I mean, it's not him. I mean, anybody wears them anywhere. And still, when I'm talking, that mic picks up. But that mic also picks up all the bounce from the wall everywhere. And you heard Pastor Cho this morning, there's a little bit of ringing echo throughout. We tried to pick out the frequency of that ringing, and we did EQ it and make it more acceptable. But, you can still hear it. Same for this mic, but this mic is not a omnidirectional. And also this mic is very close to the audio, to the sound source. So you don't hear that. Because I can lower the gain of this mic, and therefore you don't hear too many of those, or too much of those ringing.
Frank, can you share your experience? What do you mean by sounds good?
Sounds good is like
everybody has different
when few people come to the desk and complain.
Really?
Yeah, I mean, no, Ken has, I don't know if he is a regular, but he is teaching Ken how to set up certain mics this morning after, hearing certain singing. He came back and directed Ken and say, turn this off, mute that, and then boost it by certain dB, and we have experts in the audience, so.
I have people comes in every week to tell
Just one?
me.
People.
People comes in every week and tell us, oh, this is no good, and this is too much echo, and this is,
Yeah, so we deal with those kind of every week. Push the switch up and then wait a little while. Yeah. Okay.
I just have a quick question about you were talking about Pastor Cho's using the wireless mic, and then I noticed last week Zhao Zhanao also used a wireless mic. So it seems like the wireless mic pick up a lot of sounds from the surroundings. Then why didn't you guys use the stage mic anymore? Just curious.
Good question for Pastor Cho and Pastor Chow and Reverend Kwan. They prefer, okay, they like the freedom. They move around. If you recall, right, certain people using the podium mic for prayer, for announcement, they sound different. We have to make adjustments to compensate. When we pray, they bow their head and they become very close to the podium mic. And if you're not careful, the prayer will come up very loud, the first few words, and then we hurry and lower the gain. So the podium mic is fixed, but speaker usually likes to move around a little bit, and they point their head in the different directions sometimes. So yeah, it's a preference. It's just that those particular type of mic is kind of troublesome, meaning.
So in order to avoid the hums that happened during this worship today and last week, is it the best way to, if there's a hum start, the speaker should just cover their mic to avoid any more?
Well, actually, let me answer this question.
Okay.
I'm sorry. I think you're hearing some echoes at the end of the sermon, right?
So that's what I call ringing.
Yeah, that's ringing. That's really, we need to work out some logistic with the speaker, because these two we call monitor, but it's actually a speaker, L1. What we call it L1 speaker. Those wireless mic, they are very sensitive, and they pick up a lot from these two monitors. So you notice that as soon as they go up to the stage, you hear that ringing. And sometimes we are not fast enough to turn off this, because when you guys finish the praise team, he walks up.
And he starts talking right away.
And he starts talking and it starts ringing.
And then he is in a panic mode and just say, where do I stop?
I see.
So
okay.
we need to work out the logistic to ask the pastor, after you guys play your music, stop using that wireless mic.
But I think Dixon's question is more general. Dixon's question is, why don't you pick out the hum and then stop it, right? And we did it with certain EQ. It works. The things that we cannot eliminate is this stage has a lot of bounce. So when you talk, the floor bounce, your voice up the ceiling bounce it whatever way in whatever direction, and then the backcore bounce back into your mic. And then the omnidirectional mic also picks up the bounce from those walls. And that together creates a hum. So when you hold, let me borrow your mic. And I'll turn off this guy. So I'm on stage, I'm talking to you, holding this thing, remember, now, notice how close this thing has to be. So I have a low gain on this channel, meaning I'm talking pretty loud into the microphone. Now there's no humming. Now, watch if I turn on my belt pack and speak here. A little bit more. You can hear a little bit more, kind of like an echo, but I call it ringing. So that's the difference. You don't hear it here, right? So kind of like it's kind of like just acoustics. Thank you.
Would it help if we put carpets on the whole stage?
It will help a bit. It will help a bit, especially on those bounces that are getting back to the microphone. For worship team, loud music, I think we need some insulation down in the hollow space, I think. But we're going to get some expert help. Is there a microphone for Raymond?
Yeah, I agree. I think sometimes I notice, I think on the stage, there's quite a strong resonance in the low-mid frequency. So I think some kind of like carpeting or some kind of something that like absorbs sound should help somewhere, but like it needs a lot of experiment and just try and error and see what works, what doesn't.
So we noticed it yesterday when we were doing practice. I was with the worship team yesterday morning, and indeed there is a resonance. Now let me define what is a resonance, right? Resonance is, if you have a cavity, there's always a natural frequency. Actually, if you have an object, it has a natural frequency. If you hit the natural frequency, then very little excitation will result in a very massive response. That's called resonance. And so if I hit a resonance, let me give you a very, very kind of bad example, but it actually works. If you're in a bathroom stall and you try to sing the scale, you will find out where your resonance is, and you can do a little low volume, soft hum, and the whole bathroom will ring with that particular frequency. So that's called resonance. And to address Raymond's comment, yes, sound absorbent material will help a bit. What I would prefer is lower the output. But then Dixon cannot tolerate it because he has to hear his bass. So his monitor has to pump out certain amount of
I actually noticed the resonance yesterday too. Like I asked like what chord they are playing is actually like when sometimes when they play G chord or like E, that's when the booms. Yeah.
Actually, we can spot it because we have a real-time analyzer in the mixer. You can see which frequency is kind of hitting out of bounds, so to speak. Okay, but those are very good comments, and I don't have all the answers. It's just that it's something that we need to mitigate. We can never eliminate it. Raymond?
I would like to share one more thing. Actually, I heard a really good question that was asked, like, how do I know it's a good mix or how to make a good mix? I think to that thing, I have a little bit of share is that like, you have to know what a good mix is so that you can make a good mix. So I think one thing is that like listening to a lot of music and while listening, actually paying attention on how it's being done is actually very important. Like if you don't know what something should sound like, then there's no way you can make it what it should sound like. Like for drum, for example, like what does a crash cymbal should sound like? Like if you don't know, like there's no way to tell when it doesn't sound right. So also like for every instrument and also like voice, what a good mix, what it should sound like in the first place should be something that like we should already know in mind so that we can make a good mix.
Yeah, good comment. And add to that your room acoustics. So you got to play all these. I mean, what you mentioned is, yeah, the major part of the equation, and then there is certain funny things that happens in a room with the acoustics that you have to pay attention to. Okay, great, good comments, thanks. Okay, so here's something, I might as well cover this. Oh, what happened to me? I kind of pointed out where the bus sends are and also where the send on fader is. Show control. So this is a key feature that we can actually use a lot in this new mixer, and that is called show control. Basically, it's just storing your settings. So like we practice with the worship team, we use 5 vocal mics and 6 instrument inputs. So we configure all that into the faders, and then we can store them so that, come the time they march on stage after, let's say, the pastoral prayer or maybe call to worship, then, boom, all the settings are there. It may not be accurate, but close enough. Okay, so that's called show control, and point. The show control is here. Just 4 buttons here, a little button here, and that's it. And the rest is you do it with these guys. I'll show you in part 2. So we can store a large number of scenes. They call them scenes, meaning as you do a play, you have scenes, and that's how you use that term, or how they picked that term. And as I mentioned, the bus control is this, the bus send, and the send on fader. Now, to answer Kent's question, bus send is for you to send any of the 16 mix buses onto the matrix, okay? So you always see 6 targets when you engage this part. This part is the main bus. And that's where you detach any channel that you don't want using this. You can do it. I'll show you. Okay. This is a USB recorder. So I use it to record the choir. And today I have recorded the worship team. The good and bad thing is I can only record the total mix, okay? I cannot record individual tracks. So if I didn't do a right mix, then definitely I can hear it. I mean, after recording, I can hear it. If I listen to, on my headphones, everything sounds pretty good. And the reason is, I might as well. The reason is, yesterday I tried recording worship team, and then I listened. Turned out all the keyboards were kind of very soft, almost in the background. Why? Because when I was listening with my earphones, everything sounds good, and that's because from the monitors, it all sounds good. And I say, oh, it sounds good, let's record it. So there's a catch. We have to be very careful in doing this mix for recording. Now, for the audience, it's fine. Everybody can hear everything. So that's a catch. Okay, I'm going to move on. How am I doing for time? It's already 3 o'clock. Okay, I'll hurry. Now, this is kind of the result of my spending 3 months studying this thing. In the beginning, I thought you can route anything anywhere and then put the things out anywhere you want because this is a digital mixer and I can have a lot of leeways. But no, it's actually you have limited choice. You have a set of physical inputs, and those are actually physical connectors, and I saw them in the slide here. These are all your input connectors. 32 of them. Okay. So you can connect them in a limited way to any channel of your choice. I say limited because you can only route them 8 at a time. you cannot do a one-by-one matching. Okay, so there you see how the input is matched or mapped into your channels. Then you can add any channel into a mix bus of your choice, and it goes to an output through routing again. Output meaning physical output. I mean, this is already output, but it's just an audio output. If you don't route it to a connector to go to an amplifier, you don't hear anything. And then you have mix bus, and you go to a matrix bus, and then you can tell the matrix bus to send it to another output of your choice. I didn't draw the main bus, but it's by default, it's kind of here. Okay, so I hope that's it. I talked about compression, and compression I mentioned, yeah, strong vocalist, people who leads worship team but use the head-worn mics. I call them over-the-ear mics, but they're actually called head-worn microphones, you know, the thing that I'm using now. And then the drums. Drums always exceed my threshold, so I have to do compression. Okay, so that kind of completes part one. Let's. Any questions before we take a break and then come back for part two? Okay, great.